Hello students. So far we have completed like 40 sums that are related to friction and then motion of a car on a circular track, bank, road and all those sums, right? We did also see sums that were related to fictitious forces and those stuff. Okay, so those four different cases, fine. And we did also solve sums that are oriented towards like Newton's three laws and those stuff, right? So these are the sums that we did see. Okay, so around like we did see around 40 sums, right? So in this session, this is like the fifth session. Okay, so in this session we'll complete all the PYQ, fine. So there are around like 9 sums that is left. So this session will actually be the shorter session, so we'll complete it really quick. So in this session we'll also do sums that are from the year 21, 22 and 23. So those sums will also be done, including all those sums. We get around like 9 sums which we will do in this session, right? So let's move on to the next one, which is like the 41st sum. So in this question they have given you a block of mass m which is placed on a smooth wedge. Okay, so it is like placed on a smooth wedge, which means there isn't any friction between the surface and the block, right? So that stuff is done. Half inclination theta. Okay, the whole system is accelerated horizontally so that the block doesn't slip on the wedge. Okay, so this is a kind of like fourth case that we did see related to fictitious forces, right? So obvious, it should be clear. The whole system is accelerated horizontally so that the block doesn't slip on the wedge. Fine. The force exerted by the wedge on the block will be, so what will be the force that the wedge is going to exert on the block? Okay, so they're asking us to find the normal reaction. So while I'm about to draw the diagram, you'll get it. Okay, the whole system is accelerated horizontally so that block does not slip. So this is the hint that they've given over you here, which means the system has to be at rest. Okay, the block that is on that inclined plane has to be at rest, which means those two stuff has to balance. Okay, so that was the case. Then with what acceleration it should accelerate? So this is something that we have seen already itself. Okay, so the acceleration will be equal to a, that should be equal to g tangent theta. So it has to accelerate with this acceleration so that the block that is on that inclined plane is not about to fall down. Okay, so here if I draw the diagram, you'll get something like this. You are going to have a moving cart or something of that sort, and then you're having an inclined plane over here, fine. So this is going to accelerate towards the right in this case with an acceleration a, which is equal to g tangent theta, fine. And then you do have a mass that is placed inclined at certain inclination. Okay, so here obviously I'm able to balance those forces. Okay, so here if I do the free body diagram for this particular object, you'll have like mg sine theta that's going to act downwards. Yeah, so you will have like mg sine theta which will act downwards. So this will be my g. Okay, and then you will have like one more component which will be like mg cosine theta, right? So this component will be like mg cosine theta, right? So these two things will be like theta, obviously, right? So if this was like theta, then this should be my theta. Got it? So then you will have like fictitious forces, right? That ma, because of the acceleration that is happening externally, you will have fictitious forces that has been generated internally on that particular system, right? So you will have the acceleration that will be directed backwards. So that will be like ma, which will act towards the left. Okay, it should be clear, right? So if I do split this component into two parts, you will have, so this is the same splitting that I'm doing, which I have already done in the theory part. Okay, you should be clear with that stuff. So if I do split this one, you'll have like two components. One will be in this fashion and the other one will be like this one. Okay, so if I just have to match those two thetas, obviously, so this is a right angle triangle and this one is also right angle. I mean, this one is like right angle, same way this one is right angle. So obviously these two thetas has to be same, because when you place those two angles on top of each other, it will be like properly oriented. So if you do a tilt on one side, so same theta will be generated on the other side. Okay, I have made this argument already, so you should be clear. So if this was going to be theta, then obviously this one will be like theta, right? So the next theta will be like this one. Those two are just the same thing. So this component will be ma cosine theta and this one will be like ma sine theta. Okay, so this one is like ma sine theta, fine. So obviously this will be my normal reaction. So this one is my normal reaction. Got it? You shouldn't have any doubt in this part. So here, so it should be obvious that this object is not going to slide because I've given you the suitable acceleration. The acceleration was equal to g tangent theta. Fine. If the acceleration was greater than this one, obviously this will start moving upwards because ma cosine theta will dominate the mg sine theta. So these are the arguments that I have already made in the theory part. You should be clear. So here they have just clearly told us so that the block does not slip, which means acceleration is exactly equal to g tangent theta, right? Okay. So ma cosine theta and mg sine theta is just going to cancel out each other. Then what they're asking us to find is the normal reaction in, okay, the force exerted by the wedge on the block. So what will be the force that was given by this wedge on that block? So that is going to be my normal reaction. That's what I need to find, right? So n will be equal to mg cosine theta and then the ma sine theta. Obviously this is not going to fly off from this wedge, therefore normal reaction and mg cosine theta and ma sine theta has to be balanced, right? So it should be clear. Therefore you will have n, which will be equal to mg cosine theta plus ma sine theta, right? So instead of a, let me substitute this g tangent theta. So for a, I'll just plug in g tangent theta, and if I do solve this one, I'll end up getting the answer, right? So we'll get the answer straight away. So n, which will be equal to mg cosine theta plus m. So for a, you'll have like g tangent theta, that's going to be like sine theta divided by the cosine theta. Okay, and then you have got like one more sine theta into it, right? So let me do the cross multiplication and let me solve it. You'll get the answer. Okay, so if I do the cross multiplication thing, you will end up having, so this is how, okay, so if I do that one, you will have mg cosine square theta plus mg sine square theta divided by cosine theta. Okay, so then if I do factor out mg, you'll end up having mg, and then inside the bracket you'll have like cosine square theta plus sine square theta. That's obviously going to be like 1. So the final answer will be like mg divided by cosine theta. So that will be my answer. Therefore the answer over here is mg divided by cosine theta, which is like option 4. Fine. So the answer here is option 4, right? You shouldn't have any doubt in the sum. It should be clear, right? So simple sum. Okay, so the only thing is you should know a that should be equal to g tangent theta. Once you are thorough in the theory part, that should automatically fall out. Okay, you should know that stuff, right? So that is something that you need to memorize it. Fine. So if that was the case, then what they're asking us to find is the normal reaction. So wherever you have got like a, you just plug in g tangent theta and you do the solving, you'll end up getting the answer, right? You shouldn't have any doubt in the sum. Let's move on to the next one. This sum is based on the lift. Okay, so it's the second scenario that we did see related to fictitious forces. Okay, so here you have got a man weighs 80 kg. Okay, so the man weighs, so the weight of the man is like 80 kg. Fine, he stands on a weighing scale in a lift which is moving upwards with a uniform acceleration of 5 meter per second square. Okay, so they have given us the uniform acceleration with which it is moving, and then you have got what would be the reading on the scale. So what was the reading on the scale? That's what I need to find. Okay, so you are just having a lift which is going to accelerate upwards. Okay, with an acceleration that will be equal to 5 meter per second square. Okay, what they're asking us to find is the reading on the particular scale. Okay, so you have got a guy who is standing on the lift, I mean on the weighing scale inside the lift. So you will have, so two things, right? One will be mg that will act downwards. Fine. Same way you will have ma that too will act downwards. Fine. So you have got like two component. Got it? So because of this one, you will end up having the normal force that got generated inside the lift. So that will be my normal reaction. Okay, so if n will be equal to mg plus ma, right? Obviously when you look at this person from inside frame of reference, this guy isn't going to move, therefore he will push the lift downwards by mg. Same way, because of the upward acceleration, you will have like fictitious forces, so that too will contribute downwards, therefore you are going to measure more weight on the weighing scale, right? So that will be my normal reaction for a person who is standing inside a lift which is moving upwards, right? Which is accelerating upwards, right? Okay, you should be clear because we have seen this one already clearly in the theory part. So you will have like n which will be equal to mg plus ma, right? Instead of m, let me substitute what's the mass? It's like 80, right? So you will have like 80 kg, and then you have like g plus a. For g, they have given us clearly, just plug in 10, and then you'll have like 5, right? So you'll have like 80 into 15, so that's going to be my answer, right? So 80 into 15 will be like 800, and then plus 400, which is going to be like 1200, right? So the answer here is 1200 Newton, which is like option 4, right? It should be clear. Let's move to the next one. This sum is similar to that of the lift sum that we have already seen, but the only thing is they have just changed it to monkey over here, okay? But rest all other solving and concept is same based on the lift sum that we have already seen, okay? Let's do the sum, you'll get it. You have got a monkey of mass 20 kg which is holding a vertical rope, fine? So you are having a monkey that is holding a rope and the mass of the monkey is like 20 kg. First statement is done. Then you have got the rope will not break when a mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg, which means the rope will not break if the mass was equal to 25 kg. Okay, up to that limit, the rope will be stable. Okay, if it is going to exceed more than 25 kg, then obviously it is going to break. Fine. Then they have given us what is the maximum acceleration with which the monkey can climb up along the rope. So what they're asking us to find is with what acceleration the monkey can climb up the rope, which means the monkey is obviously going to pull the rope downwards. In turn, it will experience an upward acceleration with which it is going to move upwards, fine. So if it is going to pull extra downwards, then obviously the tension in the rope is going to increase, fine. So if it is going to increase, it should not increase greater than that of the 25 kg mass limit that they've given us over here. Okay, if that was the case, then with what acceleration the monkey will be able to move up. Okay, so this is same as that of the lift sum. In that lift, that entire lift is going to be pulled upwards by the rope, the tension in the rope. Okay, that entire that entire lift is going to get pulled up because of that rope, right? Same way here, the monkey is going to climb up because it is going to pull the rope downwards. In turn, the monkey will get an acceleration upwards. Okay, so same logic, same intuition. So let me draw the diagram, you'll get it pretty more clearly. Okay, so you have got something like this. You have got a rope. To this rope, that is like a monkey that is clinging onto this rope. Okay, you have got a monkey that is clinging onto this rope, and then it wants to move upwards with an acceleration of some a. Okay, so it is going to accelerate upwards. Got it? Same way, the mass mg is going to act downwards, and then you are going to have a tension that is going to get generated in this rope. Fine. So the tension in the rope is pretty obvious. So this will be the entire force that is acting upwards on the system. Fine. And the mg will be like downwards with rest force it is going to accelerate upwards, right? So if I do the force balance here, I'll end up getting the answer. So here, if I do the force balance, you'll have something like this: T that's going to be acting upwards minus mg, okay, which will give you the ma. Got it? I think we have done something similar to this to that of this sum in the previous session, right? So in that sum, we have got like a lift, and then the tension will be like upwards, and then what will be the acceleration if the tension in the rope was something, and then they would have given you the mass of this entire lift. Okay, same thing over here. Here you have got like mg, that is monkey that is holding onto the rope, and the mg is going to act downwards. Okay, so as it is accelerating upwards, obviously the tension in the rope will be greater when compared to that of this mg. With that extra force, I'm just going to pull it downwards. In turn, you'll end up getting that extra tension that got generated in this particular rope, right? So same as that of the lift sum, right? But here in this situation, only thing is the monkey is climbing upwards, that the lift was moving upwards, right? So rest all other equation will just be the same thing. Just do the solving, you'll end up getting the answer. So the maximum tension that could actually be possible over here is like 250, okay, minus mg, right? So the mass will be like 20 kg. So 20, what they've given related to the acceleration due to gravity is like 10. They've given it in the question itself, which will be equal to mass times the acceleration. So a is something that I need to get, right? So that will be like 20 times a. If I do the solving, I'll end up getting the answer, right? 250 minus 200 will be like 50, which will be equal to 20a. A will be equal to 5 by 2, that will be like 2.5 meter per second square. Okay, so the answer here is 2.5 meter per second square, with which it will be able to accelerate upwards. Fine. So obviously the answer came to be like positive, and we also know the acceleration is going to be like positive. Same way I just put in here the positive acceleration A. Therefore it is pretty obvious the monkey is accelerating upwards, which means it is pulling the rope downwards by certain extra force, balancing that of the weight of that monkey. So that extra force will be responsible for that acceleration upward, which will create an extra tension in that rope. Okay, that tension shouldn't exceed greater than 25 to 50 Newton. Okay, which is like 25 kg. Fine. So the answer here is 2.5 meter per second square, which is like option 4. Fine. You shouldn't have any doubt in the sum. It should be clear. Fine. I just plugged in 250 Newton over here. It should be clear because the maximum force that is possible over here to balance is like 250 Newton, because 25 kg equals 25 into 10, which will be like 250 Newton, right? You shouldn't have any doubt in the sum. It should be clear. Let's move on to the next one. This sum is also same like that of the previous sum. Okay, so here they have just given it straight away as the lift sum itself. A lift of mass 1000 kg, which is moving with an acceleration of 1 meter per second square in upward direction, then the tension developed in the string which is connected to the lift is. Okay, so here you have got a lift, and the mass of that lift will be like 1000 kg. Okay, that's going to act downwards. Fine. And then which is moving with an acceleration A, that's going to be like 1 meter per second square upwards, then the tension in the rope. So this is the same sum like that of the monkey sum that we have seen in the previous question. So just just do the force balance, you'll get the answer. Okay, so tension in the string is actually acting upwards, and then the mg is acting downwards, so you'll have like T minus mg. So this is kind of monkey. Okay, so T minus mg, which will be equal to the acceleration which is responsible for the upward motion. Okay, so that acceleration was equal to ma. The acceleration was positive, therefore I'm just going to take it in positive. Okay, so let me plug in the mass. Okay, m into acceleration, which will be like 1. Fine. So what they're asking is to find is the tension in the string. Okay, if I do the solving, you'll get the answer, right? So tension in the string T will be equal to T, which will be equal to mass 1000 plus, yeah, you'll have like 1000 into 10 or 9.8. You could do like two thing, but if you just look at the option, you should be clear. So 9.8 seems to be like a better choice over here, right? Because if I just plug in like 10, I'll end up getting like 11,000, something like that. But in the situation, the deviation is considerable, so those two options seems to be closer to each other. Same way in the question, they haven't given like a condition that acceleration due to gravity g is equal to 9.8 meter per second square, some 10 meter per second square, something like that. Okay, if that was the case, and when I look at the option, it seems to be suspicious that if I just plug in like 9.8, those zeros might get tallied out, and I might end up some answer that is closer to a different one other than that of the 10. Okay, so let me do it and I'll tell you. So here you will have like 1000, one thing is like 1000, and the other one will be like 1000 times 9.8. Okay, so you will have 9800 plus 1000, right? So you will have like tension T, which will be equal to 1000 plus 9800. So if you do add those two things, you will have like 10,800 Newton. Okay, so 10,800 Newton is my answer, right? See, if I just substitute here like 10, you will have like 10,000, and then 1000, you'll end up getting 11,000. In this situation, you have got like two options. Fine, so obviously I'll have to choose the option which is like more appropriate. Okay, in the situation 9.8, I could substitute 9.8 because it's like pretty closer to this value, which is like 10,800. Therefore the answer here is option 2. Fine. Okay, you shouldn't get confused in this sum. This is same as that of the lift sum that we have already seen. Only thing is here I'll have to plug in like 9.8 instead of 10. If I do put in like 10, you'll end up getting the answer which is in the option. So that's not the appropriate answer over here. So 9.8 will be the best choice. Okay, so just look at the option and see how far it is deviating in the option. With that, you'll have to choose the I'll have to choose the appropriate constants. Okay, so in this situation, when I do put like 9.8, I get much more accurate answer. So that should be my answer, right? You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is also a kind of same pattern sum that you have already seen in the previous sessions. Okay, so this is a kind of pulley based sum. Okay, so here I've got two masses as shown in the figure are suspended from a massless pulley. Got it? The acceleration of the system when they are left free. Okay, so how does it going to accelerate? So they're asking us to find the acceleration of the system, which means obviously 10g is going to dominate, 5g isn't going to dominate. Therefore, this will accelerate downwards with sudden acceleration that's not equal to like g. It will be less than that value because 5g is going to balance it. This rope isn't going to stretch. Therefore, this mass will accelerate upwards with the same acceleration, but with respect to the 5g mass, it's going to accelerate upwards. With respect to 10g mass, it's going to accelerate downwards. Fine. So whatever it is, they're asking us just to find the acceleration of the system of the masses. Got it? So let me do the free body diagram. We'll get the answer. So here you've got like 5g that's going to act downwards, right? Same way you'll have like 10 tension in the string that's going to act upwards. Got it? Here also tension in the string will act upwards. So this 5g will be like downwards. This 10g will also be like downwards. Okay. Let me do the free body diagram force balance for these two masses for which I drew the free body diagram. Okay. So if I do the force balance, you will have like tension in the string T, which will be like upwards T minus 5g. That will be equal to, yeah, 5a for the first one. I'll have to be careful with the signs. Tension was like upwards minus 5g, which was like downwards. That will be equal to 5a. And the other case will be like t minus 10g, which will be equal to negative 10a. Correct? So that's going to accelerate downwards. Got it? Here, what they're asking us to find is acceleration of the system. Therefore, I'll just equate the tension. I'll end up getting only only one unknown variable. So that will be my acceleration. Okay. So here, if I do rearrange this one with respect to tension, you will have tension T. You'll end up having tension T, which will be equal to 5A plus 5G. Here you'll have like T, which will be equal to minus 10A plus 10G. Okay. Now let me equate those two stuff. You will have 5A plus 5G, which will be equal to negative 10A plus 10G. Got it? Let me rearrange this one and I'll end up getting the answer. So you will have 15A, which will be equal to 15G. No, 5G, right? 15A, which will be equal to 5G. So that's going to be like 10G minus 5G. Therefore, it will be like which will be 5G. So you will have A that is equal to G divided by 3. Yeah. When it gets cancelled out, you'll have like G divided by 3. So acceleration A will be equal to G divided by 3. The answer here is option 2, right? You should be clear with this sum. You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is a ball of mass 0.15 kg is dropped from a height 10 meters. So I'm just going to drop a mass of 0.15 kg and the height is like 10 meters from the ground. Okay, strikes the ground and rebounds to the same height. It hits the ground and it just bounces back to the same height, which means the energy isn't lost in the situation, right? So we'll do more sums that are related to energy in the next chapter. As if now it seems to be clear that with whatever velocity it touches the ground, it has to bounce back with the same velocity. Energy shouldn't be lost. That is when it will be able to reach the same maximum height, right? Same height from where it was dropped. If there was like any energy lost, then the velocity, then the rebounds velocity will be less when compared to the velocity with which it got hit. If that was the case, then it wouldn't be able to reach that particular height from where it dropped, from where it got dropped. Okay. So it is pretty obvious, strikes the ground and rebounds to the same height, which means the rebouncing velocity is same as that, the rebouncing speed is same as that of the velocity with which it hits the ground. Okay, it should be clear. What they're asking us to find is the magnitude of impulse imparted to the ball is nearly. So what they're asking us is the change in momentum. So that is what they have given over here as impulse because the time interval is very short. Fine. So let me draw a diagram to understand this one clearly. So it's just going to drop a ball from certain height and it hits the ground with an velocity v. with some velocity, and then it's going to bounce back. It's going to rebounce back with the same speed, with the same speed but in the opposite direction. Okay, so the magnitude of velocity is just the same thing. That is when it will be able to reach the same height. Okay, so this case, in this situation, energy wasn't lost. Therefore, if whatever velocity that it hits the ground, it had the same velocity but in the different direction, and then it moved upwards to the same height. Okay, there isn't any energy loss. Fine, it should be clear. So if that was the case, first let us find what will be the magnitude of this particular velocity. If I get the magnitude of that particular velocity, then obviously in order to get the impulse, it's like final momentum minus the initial momentum. They've given us the mass of that stuff. If I do get the velocity, if I do get the magnitude of the velocity, then obviously I'll be able to put in final momentum minus initial momentum. That will give me the change in momentum, right? So let me do the solving. You'll end up getting the answer. So you will have v square. So I'll have to use the kinematic equation, right? So the third kinematic equation suits best because velocity and distance is something that I'm going to match. Therefore, you'll have like v square minus u square, which will be equal to 2as, right? It should be clear. So here, I'm just going to drop it, right? So as I'm dropping it from certain height, the initial velocity will be like 0. Therefore, the initial velocity was like 0. V square will be equal, v will be equal to root 2gh, right? So v will be equal to root of 2 into g. They have given us like 10 meter per second square, and the height will be like 10 meters, right? Yeah. If I plug in, you'll have like velocity. The magnitude of this velocity will be equal to, yeah, you will have 10 root 2. Okay, 10 root 2 meter per second square. It should be clear. Now I've just got the magnitude of that particular velocity. What I need to find is actually the change in momentum. So to get the change in momentum, it will be like final momentum minus the initial momentum. Final momentum was directed upwards, so that's going to be like positive. Mass will be like 0.15, right? So let me factor out the mass. So we'll have like 0.15 final minus the initial, right? So final will be directed upwards. That will be like 10 root 2 negative of the initial. That too was like downwards. So negative of negative 10 root 2, right? So these two things will get added, right? You should be clear. I'm just doing it straight away and quick. You should get the understanding, right? So these are like simple sums, right? So we'll have like 0.15 into 2 times 10 root 2. Okay, so that will be like 20 root 2. So these two things will get added, fine. So if those two stuff gets added, you'll have like 20 root 2. Yeah. So if I do the multiplication, you'll have like 1.5 times 2. So that's going to be 1.5 times 2. So that's going to be like 3 root 2. Yeah, right. So you'll have like 3 root 2. Okay. Yes. So instead of root 2, I'll just substitute like 1.4. So 3 into 1.414 or 1.4 will give me the answer, right? So 14 into 3, you will have like 12, it's like 4.2. So the change in momentum over here is like 4.2 kg meter per second. Got it? So here the answer here is 4.2 kg meter per second. Again, that gives me the change in momentum in this situation. Got it? The answer here is option 3. Yeah, you shouldn't have any doubt in the sum. It should be clear, right? So this is like a simple sum, right? So the only thing that we need to know is energy is conserved, which means with whatever speed it hits the ground, it is going to bounce back with the same speed. Only thing that I've changed is the direction over here, right? You shouldn't have doubt in the sum. Let's move on to the next one. This sum is based on momentum conservation. Let's see what the sum is. A shell of mass m is at rest initially, okay? So it is at rest initially. It explodes into 3 fragments having mass in the ratio of 2:2:1. Got it? If the fragments are having equal mass, fly off along mutually perpendicular direction with the speed v. So obviously, so the mass that is having equal mass, I mean the part that is having equal mass is going to fly off mutually perpendicular with the speed v. Fine. The speed of the third lighter fragment is, okay. So with what speed the third fragment is going to fly off? That's what I need to get. Got it? So the sum is easy. We have seen these kind of sum already itself. So you are just going to have a mass And then I'm just going to split this mass into 3 pieces. Okay, so you'll have pieces that's going to be like 2m and then 2m and then m. Got it? So these two m's are going to fly off at mutually perpendicular to each other, which means one if one was like plus j cap, then the other one will be like I cap, something like that. Okay, so that is how I've taken over here with the velocity v, with the speed v. Okay, so I just know the speed. So what I need to get is the velocity of this third part. So velocity v3 has to be found. The speed of the velocity, the magnitude of the v3 has to be found. Okay. So to get that one, initial momentum will be equal to final momentum. Obviously, the initial momentum was equal to 0. So then what should be my final momentum? It will be like 2m v I cap for the first one, and then you'll have like 2m v j cap, and then you have got like the third momentum. So that is something that I need to get, right? So P3 is something that's unknown over here, fine. So if I do the solving, vector P3 will be equal to negative 2mv I cap negative 2mv j cap. So that will give me the vector P3. So that stuff is done. What they're asking us to find is the speed, which means just they're asking us to find the magnitude, right? So I just need to get rid of this mass to get the speed. So to get the speed, what I need to do is I'll have to take the modulus over here, right? If I get the modulus of this above equation, you will have modulus of vector p3 will be like mass of the lighter particle is like m, and then the velocity, speed of that velocity will be like v3. Okay, the magnitude of that velocity, which will be equal to the root of, you will have, so negative, obviously I'm going to square it, so it will become positive. So you'll have like 2mv the whole square plus 2mv the whole square, right? If I do add those two parameters, you will have 2 2mv the whole square, which will be like 4m square v square, and then you'll have like 4m square v square, which will give me like 8m square v square, right? So that will be equal to m v3, which is like 2 root 2, right? M square v square, if I take square root of it, you'll have like mv, and then you'll have like 2 root 2. Got it? M will get cancelled out, and then only stuff that will be left is the speed of the third particle v3, right? So the speed of the third particle will be like 2 root 2v, which will be the option 4 here. So the answer here is like option 4. It should be clear. You shouldn't have doubt with the sum. So this kind of sum is, I think we have seen in the second session itself. So you shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is a football player is moving southwards and suddenly turns eastwards. Okay. So he is changing some direction with the same speed to avoid an opponent. Fine. The force that acts on the player while turning is, so what will be the force that is acting on that particular player? That's what I need to find. Okay. So first let me draw the direction. So a football player is moving down southwards, which means downwards, and then he is turning towards the east. East here is like towards the right. Got it? To avoid the player with the same speed. So here also it was like v. Finally also it was like v. Got it? What they're asking us to find is the force that acts on the player while turning is. So force is nothing but the change in momentum divided by the time interval, right? Yeah. So to get the force, what I need to do is change in momentum and its direction divided by the time interval. So here they are not asking us to find magnitude of something that sort. Number is not something that I need to get. Only thing is I just need to get the direction with which the force is going to act. So the direction of the change in momentum and the direction of the force is going to be same. Okay. So to get the direction of the change in momentum, what will I do? I'll just plug in final momentum, vector final momentum minus the initial momentum, right? Got it? So to get the final momentum minus the initial momentum, so let me put in like mass. So that's the only parameter that is left over here. So mv, so this will be like mv. Okay. So this was like final momentum was along the direction plus I cap, and the initial momentum was along the direction minus j cap. Got it? Okay, so if I do subtract those two stuff, I'll end up getting the change in momentum. Therefore, change in momentum del p will be equal to final minus the initial. So final will be like mv I cap minus the initial, that will be like negative negative, it's going to become positive, therefore you will have plus mv j cap. Got it? So the direction of the change in momentum will be along plus I cap and then the plus j cap, right? So plus I cap and the plus j cap will be like something like in this direction. Okay, so the force should act on this guy in this direction. Okay, so that is when he'll be able to change his orientation towards the eastwards direction. Fine. So obviously final momentum minus initial momentum will give you certain magnitude. So when you look at that, I mean, like, will give you certain vector. When you look at that vector, obviously that will give you the direction of the change in momentum, which is nothing but the direction in which the force has actually acted on that particular guy. Okay, so here it is pretty obvious, the direction of the change in momentum is like plus I cap and then the plus j cap. So it is acting in this inclination, and obviously I and j has the same magnitude, therefore it will be along north east. Yeah, I mean northeast, right? So the answer here is along northeast, which is like option 3, right? So just get the change in momentum, you'll end up getting the direction. Fine, you shouldn't have any doubt in the sum. So this is also one of the easiest sums, right? Let's move on to the next one, which will be the final question for this session. In this question, they have given us calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. Fine. So with what maximum acceleration I could actually move on that particular car so that the body that is going to stay inside that car isn't going to move. Okay, which means friction is good enough to balance that particular object to stay stationary inside that frame of reference. Okay, so this sum is same as that of the first situation that we have seen with respect to the factitious forces. Okay, you should get it. So here what they the next thing that they've given is the coefficient of static friction between the body and the floor is 0.15. So they've given us the coefficient of static friction, so mu s is given. What they're asking us to find is actually with what maximum acceleration that particular car or truck could accelerate. So that's what I need to get. Okay, so let me draw the diagram, you'll get it. So you're just going to have a truck in the situation. Let us consider it to be like truck itself. Okay, so you're going to have a truck that's going to accelerate upwards, and then you are going to have an object that is inside that particular vehicle. Got it? So n mg, those two things will get cancelled, and then here friction is going to put this box in that particular position itself, and then there is going to be a fictitious force that's going to act opposite to that of the external cause. Okay, so friction has to balance this ma, that is when this entire system will be at rest. Okay, so let me do the force balance, you'll get the answer. If I do the force balance, you'll have like F that is acting towards the plus, and then minus ma. So these two forces should balance such that this object is going to be at rest when you look at this object from inside that particular vehicle. Okay, so the acceleration, so the resultant acceleration of this particular object is going to be 0. So F minus ma will be equal to 0. It should be clear. F minus ma will give you 0. So instead of F, let me plug in like mu s n, right? So for mu s n, let me put in like 0.15 into n. That will give you like the mass. Yeah, they haven't given anything related to mass. It's going to get cancelled out because of the 0 on the right hand side. So m, and then the g will be like 10. They have given us 10. That's what I need to take over here. Minus mass times the acceleration. Acceleration is something that I need to get. Okay, so here in this situation, m will get cancelled out, because if I just factor it out and then move it to the denominator on the right hand side, you'll end up having like 0 by m, which is going to be 0. Got it? So a will be equal to, I got the answer, that's it. So a will be equal to 10 into 0.15, that will be like 1.5 meter per second square. So I could actually move with an acceleration of 1.5 meter square, so that the particle or the object that is inside the vehicle isn't going to move, because if that was the case, then the friction will be good enough to balance that object. If the acceleration was greater than that one, then friction wouldn't be able to balance it. With rest small acceleration, it will start moving other direction, which means backwards. Okay, with respect to the truck or vehicle, whatever it is. So the answer here is like Option 3, 1.5 meter per second square, right? You shouldn't have any confusion regarding these kind of sum, right? We have already seen exhaustively. Even in the theory, I've just taught you like very clearly. If you're just clear with those concepts, those four different fictitious forces from this chapter, whatever question that they're asking you, right? So fictitious forces is just going to work in that particular fashion, right? You should be clear with all those sums that we have discussed so far. All those 49 sums, you should be clear with those different patterns that we have seen, right? Once you're thorough in these different kind of patterns, obviously you'll be able to do all those sums that they're asking you in the exam. Okay, right? So you shouldn't have any doubt. With this, the video is completed. Bye.